Have you ever wondered how scientists actually work with those massive simulations of the universe, the ones with billions of particles flying around? I mean, how do you steer something that complex in real time? You can't just stop and rewrite the code for every little tweak. Well, that's exactly what we're diving into today, how to command these unseen virtual worlds. So that's the big question, right? When you're dealing with incredibly sophisticated software like GN4, the kind they use at places like CERN, you just can't afford to recompile everything just to bump a particle's energy up by 1%. You need a way to talk to the simulation while it's actually running. And the solution? It's brilliant. You build a powerful text-based user interface right into the simulation itself. Seriously, think of it like a command line, but instead of controlling your computer's operating system, you're controlling a virtual universe. It gives scientists direct, hands-on control over the experiment. All right, so here's our game plan. First, we're going to talk about why these custom commands are such a game changer. Then we'll pop the hood and look at the core components and the toolkit you get to play with. After that, we'll build a virtual particle gun, figure out how to manage all-to output, and finally, we'll see just how much power this whole system puts at your fingertip. So, why is this so critical? Well, because these custom commands are what turn a simulation from a rigid, one-and-done program into a flexible, interactive laboratory. It becomes a place where scientists can really explore and experiment on the fly. And you can really see the difference here. The old way, you'd change one little parameter in the code, then wait, and wait, for it to recompile, and then run it. The GN4 way, you just type a command and see the result instantly. It's the difference between sending a letter by mail and having a real-time conversation. Okay, so this whole system really boils down to just two fundamental pieces, the messenger and the command. If you can get your head around these two, you've pretty much understood the whole thing. First up, we've got the G4U messenger. The absolute best way to think about this is as a dedicated delivery service. Its only job is to listen for the commands you type and make sure they get routed to the exact right place inside the simulation. And well, if the messenger is the delivery service, then the G4UI command is the package it's delivering. This is the actual instruction. It defines what the command is called and what kind of information it needs, like a number or some text, to get the job done. So the whole flow is actually super simple. You, the user, type a command. The messenger, which is always listening, grabs it. Then it delivers that command to the right destination, let's say the particle gun, and that part of the code carries out the instruction. It's just a clean, direct line of communication. Now the best part? You don't have to build all these command types from scratch. Nope. GN4 gives you a whole toolkit of pre-built commands, each one designed for a specific kind of task. Let's take a look. This table really shows you how versatile it is. Need to set a simple number, like how many particles to simulate? There's a command for integers. Need to give the name of a particle, like proton? There's a command for that. But here's where it gets really powerful for scientists. There are commands that understand both a number and its unit. So you can set an energy to 100 MeV or a position to 5 centimeters, which is not only easy, it helps prevent some really critical mistakes. Okay, enough theory. Let's make this real. We're going to build a user interface, piece by piece, for a virtual particle gun. The thing that actually shoots the particles into our experiment. First things first, you got to get organized, right? So we create a directory. This is just like making a folder on your computer. It lets us group all of our particle gun commands together under a nice clean path. /gun. Keeps everything tidy. Next up, we need a way to choose what kind of particle to fire. Since a particle's name is just text, we use a string command. Now, the user can literally just type /gun/particle proton, and the simulation knows exactly what to do. It's that simple. Now, this is where it gets really smart. To set the particle's energy, we use a command that understands both numbers and units. This means a scientist can type /gun energy 500 MeV or /gun energy 0.5 GeV, and the system is smart enough to handle all the conversions automatically. How cool is that? And finally, we need to set the starting position. For this, there's a command that's built to handle a 3D vector, your X, Y, and Z coordinates, along with a unit. So a user can type /gun position 0, 0, 10 centimeters, and the gun knows precisely where to fire from, no ambiguity. So let's just step back for a second and look at what we did. With just a few simple lines of code, we've built a complete interactive control panel. We can now change the particle type, its energy, and its position all on the fly, without ever having to recompile the source code. That's incredible.
But, a good conversation is a two-way street, right? A great interface isn't just about sending commands in, it's also about controlling the information that comes out. Scientists need to be able to capture all the logs and data the simulation produces.
And the process for this is pretty straightforward. It's kind of like a three-step dance. First, you create your own custom receiver that knows what to do with any text the simulation prints out. Second, you tell the main interface, hey, from now on, send all your output to my new receiver. And from that point on, your receiver can do whatever it wants with that text. Write it to a log file, display it in a custom window. You have total control.
So as we start to wrap this up, let's pull back and think about the big picture. What's the real impact of having this kind of dynamic, command line control over a seriously complex scientific simulation?
Here's what it all boils down to. A good user interface like this doesn't just add a feature. It transforms a static program into a living, breathing research tool. It empowers scientists to ask new questions, test new ideas, and get immediate feedback, which just massively speeds up the pace of discovery. This level of interactive control really isn't just a nice-to-have anymore. It's essential for modern science. And it makes you wonder, when our tools become this powerful and this flexible, what new doors does that open? What new frontiers can we start to explore? What problems can't we solve?